Let's take a look at percents and take a look at our first problem here. Got 23%, and we want to change from percent to decimal. So change from percent to decimal. Now some of these problems will have fractions in there. So the first step I'm going to put down here doesn't really apply to this problem, but it'll say get rid of fractions. And we'll do that with division, which we'll see. This one there is none. Let's carry down the 23%. And then change from percent to decimal. We're going to move the decimal 2 places, decimal point I should say, decimal point 2 places to the left. Now if I were to put a decimal here, we just have 23, the decimal point would be right there. And move it 2 places to the left, so move it over there, and our answer will be 0.23. Let's look at our second problem. We've got 42 2/5%. Now remember our first step was to get rid of fractions. If I come over here, 2/5, if I do division, 2 divided by 5, put a decimal here, 5 doesn't go in 2. Where your answer will have a decimal right straight above that other one. Then we add a 0 on, 5 does go in 20, 4 times. 4 times 5 is 20, and then that gives me 0. So this right here, this is a mixed number. That's the same as writing 42 plus 2/5%. And we just said that 2/5 is 0.4. So this would give us 42.4%. So that's step 1. Get rid of the fraction. Now step 2 is going to be to move our decimal 2 places to the left. If I were to put one, it's right here. Or, sorry, there is one right there. So I'll move it 2 places to the left. I'll wake up here eventually. And our answer will be 0.424. Let's look at number 3. We've got 1 and 1/8%. Well, if I come over here and do 1 divided by 8, here's my decimal point, and the answer will be straight above that. 8 doesn't go into 1, so that's 0. So I add another 0 here. 8 does go in 10 one time. 1 times 8 is 8. 10 minus 8 is 2. Add another 0. Put a 0 there. 8 goes into that 2 times. 2 times 8 is 16. Subtract that. Add another 0 on. And 8 does go in 45 times. So again, this is a mixed number. And it looks like 1 plus 1/8%. And we just said 1/8 was 0.125. So adding these together, that gives us 1.125%. And now we need to move our decimal 2 places to the left. So move it 1, 2, and now there's nothing here digit-wise, so we always can add 0. So our answer is 0.01125. And that'll be our answer. Now this next one is going the other direction. It's a little bit easier. We got 0.815. And it says convert from decimal to percent. So convert from decimal to percent. What we're going to do is move our decimal point two places to the right, and add on a percent symbol. Okay, so for this problem, here's my decimal. We're going to move it two places to the right. So we get 81.5%. And that's our answer. Now here we got 9.1. And some instructions convert from decimal to percent. And it doesn't matter if it doesn't look like a decimal. It still is. We still follow this. Move it two places to the right. There's 1, there's 2. And again, we don't have a digit here, so we can put a 0. So this becomes 910%. It didn't seem quite right, 9.1, but it doesn't matter. You still do it, and we actually see it's quite a big percent. Let's look at this one. 0.02. And it says to convert from decimal to percent. Well, still, move your decimal point two places to the right. There's 1, there's 2. Excuse me. And that gives us 2%. And that's our answer. Okay, this says convert from decimal to percent. Well, this is another one that has a fraction in there. So we're going to get rid of the fraction. It's kind of hard to move your decimal point if you don't, if you have fractions in there instead of decimals. So if I come over here, 1 divided by 4. 4 goes in 10 two times. The decimal point goes straight above there. That's 8, then 2, and then add another 0 on. 4 goes in 25 times. 5 times 4 is 20, and then subtract that and I get a 0. So this becomes 2 plus 0.25, which is 2.25. And we're wanting to go from decimal to percent, so we're going to move our decimal point two places to the right. So this will become 225%. And that's our answer. Let me save that. And this is percents, page 01. And bring up a new tablet. There we go. Okay, let's look at the next problem. It says 80 is what percent of 210? Now, some people memorize formulas to deal with these. The book kind of implies setting them up as proportions. A good chunk of the percent problems, if you identify what certain words mean, then you can easily set it up. Now here all they want us to do is set up the problem but do not solve. Where the is your equals. So then it equals right there. And 80 is before the is, so this is 80 equals. Now the of is always your times. So that's your multiplication. And then we got what percent? Well, that's going to be our x times 210. And I can flip these around. X times 210 gives us 210x. And that's our setup. Let's look at our next one. 30% of what number is 125? Well, again, where is our equals. So there's equals. And 125 is to the right of it, so I'll put 125 to the right of the equals. The of is our times, our multiplication. So this is saying 30% times what number? That would be our x. Now, they say don't solve this, but when we get ready to, don't forget, if you, well, I shouldn't say don't forget, but some of you may never seen this, but we never want it in percent form when we're solving a problem. So this would be 0.30x equals 125, and then we'd solve it from there. We always put it in decimal form, so we move our decimal point 2 places to the right. Okay, this one we got what is 3 1/4% of 200. Where the is our equals. Now what has to be an x, a variable, and this will be 3 1/4% of means multiplication, so times 200. Now don't forget the 3 1/4%. If we were to go through, we're not going to solve this, but that's the same as 3 plus 1/4%. And if I were to do this by hand or check on my calculator, 1/4 is 0.25. So this become 3.25%. And then to go from percent to decimal, we move it 2 places to the left. So it'd be 0.0325. And that's the value we'd want to use in this problem. But all they're wanting is set up. Okay. This one's a little bit weird. Out of 300, 180 is what percent? Well, where the is your equals. What percent? That has to be x. And out of 300, 180. What they're implying there is we got 180 over 300. Now this is going to give us a decimal, and it's asking us for the percent, so we're going to need to move our decimal place 2 places to the right when we're all done, which we'll see with some examples, but thought I'd mention it there. This one, we got 5 2/3% of 300 is what? Well, the is where your equals goes. That's equals. What is your x? And here we got 5 2/3%. Of is a times, so we're multiplying times 300. And that'd be our setup. Again, we'd have to convert the 5 2/3% to decimal first. Now, by the way, the 5 2/3% comes out to like 5.66666 going forever. Now, you could sit there and try to worry about an exact value, or you could just take this out like 5 or 6 decimal places and then convert it to decimal. I guarantee if you take it out that many decimal places, no kind of rounding will ever amount on that in terms of what you're going to do with it. Well, these next problems are actually asking us to solve them. So let's do that. 30 is what percent of 80? Well, the is our equals. Put 30 there. What percent of? The of is our times. The what percent is going to be our x, and then the of 80, that's times 80. Now we're trying to get x by itself. So what we can do here is we can divide both sides by 80. Because a number right before an x indicates multiplication. And those 80s would cancel. And 30 over 80, they end at 0, so they're both divisible by 10. So that gives us 3/8. And I'll change that to decimal form. Don't want fractions when working with percents or decimals. 8 doesn't go into 3, it does go into 30. Goes in that three times. 3 times 8 is 24. Subtract that, and we get 6. We add another 0 on. That goes into that 7 times. 7 times 8 is 56. Subtract that, we get 4. Add another 0, and 8 goes into 45 times. 5 times 8 is 40, and then that gives me 0. So this becomes 0.375. Okay, so what percent? Well, change this back to percent form. We're going to move our decimal point 2 places to the right. So our answer here would be 37.5%. And let me save that and start a new tablet. There it goes. And let's look at problem number 14. It says 60% of 210 is what? Well, again, where the is our equals. The what has to be x. The of is multiplication, so this is saying take 60% times 210. And for the percent, we want to change it to decimal before we use it in the calculation. So we move it 2 places to the left, and it'd be 0.60 times 210. Now I'm going to multiply those two together. 210 times 0.6. You can drop off trailing zeros. 6 times 0 is 0. 6 times 1 is 6. 6 times 2 is 12. The 0 here doesn't matter. We got one decimal place, so I need one decimal place in my answer. So my answer will be 126. Now a lot of times with percent problems, you can look at it and see if it even makes sense. 60% of 210 is what? Well, that seems reasonable. You know, half of it would be 50%. Half of this is 105. So 126 does seem very reasonable. You know, if you're not that great at percents and you're in the medical field, well, if you're having to do anything by hand or even just in nursing school or something, it doesn't hurt to use that quick check there to see if it even makes sense. Might save you giving too much medicine to somebody, or save you from missing a problem on a test. Let's take a look at this one. Find 7% of 740. Well, find, we're trying to find a value, so that's like x. And 7% of is our multiplication, so there's saying take 7% times 740. And that was number 15, yeah, okay. Well, we want to change that to percent form. So this would be, or decimal form, that'd be 0.07 times 740. So let me come over here, multiply those together. 7 times 0 is 0, 7 times 4 is 28, put the 8, carry the 2, 7 times 7 is 49, 51. 2 decimal places here, so 2 decimal places here. So that would give us 51.8. Now, 10% of this, if I broke this, divide this by 10, that'd be about 74. So 51.8 does seem very reasonable for 7%. Let's take a look at another one. We got 20 is what percent of 20? Well, the is where equals goes. So we got equals there. 20 is here. What percent of? This is x times 20. X times 20 is just 20x. And again, that's multiplication, where you got 20 times x. So we're going to divide both sides by 20. And those 20s cancel there. And we got x is equal to 1. But it says what percent? Well, if I were to put a decimal there, it'd be like right here. And we will move it 2 places to the right. So move it 1, 2. So I'm going to need to add on a couple zeros there. So our answer is 100%. Let's take a look at another one. Got 120 is what percent of 300? The is again our equals. And we've got 120 here. The of is our multiplication. What percent will be our x times 300? Which will be 120 equals x times 300 is 300x. Then I want to divide both sides by 300. Like this. And that 300 cancel that. Got x is equal to this, and they both end with 1 0, so I can drop the 0 off. So that's 12 over 30. They're both divisible by 6, so that gives me 2/5, like that. And that's as much as I can simplify that. Let's put it in decimal form now. So I'll do 2 divided by 5. Here's where my decimal point would be, so my answer is straight above it. 5 doesn't go in 2, but it does go in 20 4 times. 4 times 5 is 20. Subtract those and we get a 0. So this becomes 0.4. And this is in decimal form, so we want to change it to percent, because that's what they're asking for, is what percent. So I need to move it 2 places to the right, and I can always add zeros on. So 2 places to the right, and this would become 40%. 120 is 40% of 300? Yeah, that seems reasonable. Half of 300 is 150, so 150 is 50%. Let me save that. And I don't know why it keeps flipping me out of that. It's not a very good product, but it's cheap. So I can't complain too much. Now this one says we got 30% solution. And it says percent strength. What is the ratio of pure drug to solution? And simplify if necessary. We'll talk about this in ratio form. But basically, in fraction form, 30% solution means we got 30 parts of drug to 100 parts solution. So this is just 30 over 100. It's always whatever this is, you just put it over 100. And this simplifies. They both end with 0, so I can divide top and bottom by 10. So that gives me 3/10. And putting that back into ratio form is 3 to 10. Okay. Let's take a look at this one. Now, everything else in this section I've kind of talked about. You can set up in proportions to solve it, and I think it's easier to do it in the manner I showed you. But this one really does fit well with proportions. Some things you have to force to get into proportions. It's much easier to do it via another method. This one says doctors ordered a 5% saline solution to be prepared. How many grams of pure drug will be needed to make 40 milliliters of solution at 5% strength? Well, 5% solution. That's 5 over 100. That's what we just looked at up above. I could simplify that if I wanted to, but I'll just do the equals. So down here's our total. And so this is going to be our total. And then this right here is going to be the drug part. So it says, and this is a little bit different, how many grams of pure drug will be needed to make 40 milliliters of solution? Well, this was our total solution down here, wasn't it? So we're going to put 40 down here for our 40 milliliters. And how many grams of pure drug? So again, we're going to put the X up here. Now remember what this represents. This is our parts of the drug. So 5 parts of drug. And I can't read that, but let me shorten it. This is our drug part, and this is our solution part. So over here, they say 40 milliliters of solution. That's why we put 40 down here. It matches that. And this is how much of the drug do we need? Well, this is a proportion, and with proportions you can cross multiply to solve them. Proportion is where you got a single fraction equal to single fraction. So what we can do is we take the 100 times x, so that gives us 100x, and 5 times 40. Well, 5 times 40 gives us 200. And then we want to divide both sides by 100 to get the x by itself. And these hundreds cancel. And 200 divided by 100 gives us 2. And whatever that be in grams, or how many grams? So that'd be your answer. Let's look at another one of those. Doctors ordered 5% saline solution to be prepared. How many grams of pure drug will be needed to make 80 milliliters of solution? So this would be 5 over 100 again, equals 80 is our total, and then how much drugs? Again, we'll cross multiply like this. So 100 times x is 100x, and 5 times 80. 5 times 80 gives us 400. And then divide both sides by 100 to get rid of the number before the x. And those hundreds cancel there. And 400 divided by 100 gives us 4. And I'm assuming this is grams again. To make, how many grams? Yeah. So that'd be our answer. And that's actually the last problem, so let me go ahead and save this. Then I'll stop the recorder.